This is Mr. B. Giriraju, Professor of EC Department, ACE Engineering College. Now I would like to explain subject electronic measurements and instrumentation. So before going to start this subject, I will suggest textbooks. They are Modern Electronic Instrumentation and Measurements Techniques, A.D. Albenics, W.D. Cooper, PhD 2003. Second textbook, Electronic Instrumentation, H.S. Kalsi, TMH, second edition, 2004. So better to refer textbook Electronic Measurements and Instrumentation, K. Lalakishore, PSN Education, 2010. So actually this is the 5-unit syllabus. Now I will give course outcomes of the subject. So Unit 1, an introduction to measurement techniques and instrumentation design and operation. Unit 2, study about the construction and working principle of various types of signal function generators and various types of wave analyzers. Unit 3, study about the basis of oscilloscope and its applications, Lissajous method of frequency measurement and time measurement, standard specifications, various types of probes. Unit 4, study about the transducers, their classification, also about thermocouples, thermistors, sensistors. Unit 5, study about the bridges and measurement of physical parameters like force, velocity, pressure, moisture, etc. Also study about data acquisition systems. So in the same way I will explain course objectives also. After completion of this course, student will be able to describe the fundamental concepts and principles of instrumentation, apply the measurement techniques for different types of tests, understand principle of operation, working of different electronic instruments. Learners will apply knowledge of different oscilloscope like CRO, DSO. Student will understand function transducers and its working. Student will understand functioning of bridges and physical parameters performances. So these are the course objectives. So before going to start Unit 1, I will give brief introduction about the electronic measurement and instrumentation. Actually, what is the meaning of instrumentation? Instrumentation is a technology of measurement which serves not only science but all branches of engineering, so medicine and every human endeavor. Actually this is the combination of different types of electronic circuits. So what is the measurement? So with the help of instrument we can measure quantity. Generally this involves using an instrument as a physical means of determining a quantity or variable. So what is electronic instrument? Electronic instrument is based on electrical or electronic principles for its measure problems. So now I will start Unit 1. Here Unit 1 is the block schematics of measuring systems. So actually in this system, so we are having block diagram measurement system. So as shown in like this. Actually this is having 4 blocks. Your first block represents measuring. Second block transducer or primary sensing element. Third block pre-amplifier or signal conditioner. Output device. These are the blocks in block diagram of measurement system. So your measurand is the quantity to be measured. So your measurand means that may be either resistor or capacitors like that. With help of meter, you can measure value of the quantity. So next block is the transducer or primary sensing element. So here the function of the transducer is converts one form of energy into other form. That means this will convert non-electrical variable into electrical variable. So another name of the transducer is pickup element. According to transducer classifications, we have 5 types of transducers. First one, based on transaction principle. Second one, passive or active transducer. Third one, digital and analog transducer. Fourth one's primary and secondary transducer. Fifth one, transducer and inverse transducer. These are the classification of the transducers. So actually here I am taking 2 types of transducers, passive transducer and active transducer. Here the function of the passive transducer, it requires an external power for their operation. Examples: resistive transducer, capacitive transducer and inductive transducer. Active transducer, it does not require an external power for their operation. Actually these are the self generators. Examples: piezoelectric material and photovoltaic cell. So these are the self generators. So next block, free amplifier or signal conditioner. So actually here output of the transducer is a weak signal. Now we have to improve the output of the transducer with the help of free amplifier or signal conditioner. So actually a free amplifier signal conditioner used to amplify or modify the incoming signal from transducer. Examples: amplifier, multiplexer, A to D converter, like this. Next block is the output device. So here the main aim of the output device used to display and analyze the output. Examples: CRO and X2Y recorder. So now these are the blocks of the measuring system. So actually here I am showing example digital multimeter and analog multimeter. This is the animation of the digital multimeter and analog multimeter. So here I am taking measurand as resistance, but in that resistor passing through some voltage. Now I want to measure voltage passing through resistor. So here probes will act as a transducer. Now we are connecting transducer between measurand and electronic system. A digital multimeter is electronic system. So now I am measuring voltage passing through resistance in the meter. Now I am showing in 2 forms, digital and analog meters. So this is the function of the measurement system. So to understand measuring systems, we require performance characteristics of instruments. Here performance characteristics of instruments can be classified into 2 types: static characteristics, dynamic characteristics. Now I am going to explain static characteristics. So actually here static characteristics are the memoryless characteristics. So to remember these characteristics, we don't require any memory. Static characteristics of instruments are used to measure an unvarying process condition. Such type of related definitions are instrument. Instrument used to determine the present value of the quantity. So whatever the quantity, with the help of instrument you can measure value. Measurement means the process of determining the amount of degree or capacity according to standards of the instrument. So actually every system having some standards. In the same, every system having some expected value. Expected value means designed value. So now with the help of instrument you can measure quantity. Accuracy means the degree of closeness of a measurement compared to the expected value. Here expected value is the design value. So now I want to calculate accuracy. So here I have taken to calculate accuracy one example. The expected value of the current through a resistor is 20 milliamps. However, the measurement yields a current value of 18 milliamps. Calculate the relative accuracy, percentage accuracy, absolute error and error. Now I am going to calculate accuracy of the instrument. So here accuracy you can express as 1 minus mod yn minus xn divided by yn, where yn is the expected value, xn is the measured value. In this problem I have given YNU as 20 milliamps, XN as 18 milliamps. So now we have to simplify accuracy by the using given values. Now accuracy is 1 minus 2 milliamps by 20 milliamps. Simplify them, you will get accuracy 0.9. Now percentage of accuracy equal to accuracy into 100. Your accuracy A equal to 0.9 into 100, 90%. Here 90% is the percentage of accuracy for the given system. So fourth one, expected value, the design value. Actually every instrument having some design value. Next one, precision. Precision means sharply or clearly defined. It is the measure of degree to which a particular parameter is measured. So here precision mathematically can be expressed as P equal to 1 minus mod xn minus x bar n divided by x bar, where xn value is the nth measurement, x bar is the average of the set of value, set of measure values. To calculate precision, you have to consider group of the readings. Among in that readings, you have to choose particular one. With the help of that reading, you can calculate precision. Now, I am going to calculate the precision of the given values like this. Here I have taken 5 readings, 49, 51, 52, 50, 49. Among these values, I have taken particular value as 52. Now, I will calculate precision for the 52. So, according to our explanations, we know the mathematical expression of the precision P. P equal to 1 minus xn minus x bar n by x bar n. So, first calculate average value of the xn. So that we can write x bar n is equal to x1 plus x2 plus x3 plus x4 plus x5. Actually here I have taken 5 values. I am writing in the form of x1, x2, x3, x4 and x5 like this. Substitute for the given values in the above formula, then we will get our required arithmetic mean or average value equal to 50.2. So now choose third measurement value xn equal to 52. Now in the place of xn, x bar n substitute for the given substitute for the given values, then p equal to p means precision equal to 1 minus where xn is the 52 minus x bar n is the 50.2. So if I calculate them, then you will get 0.964. That means now your percent of precision equal to 96.4. This is the some basic idea about the precision. So next, resolution. The smallest change in the measured value to which the instrument can be respond. So this is called the resolution. Error. The difference between the measured value and true value. So we can say in another way, the difference between the measured value and the expected value. This is called the error. So now I am going to calculate error of the instrument. In the previous problem, I have taken expected value yn is equal to 20 milliamps and measured value 18 milliamps. Now error equal to difference between the expected value and measured value. Substitute here, then you will get error equal to 2 milliamps. So now going to calculate first percentage of error. Your percentage of error equal to error divided by expected value to 100. You know the value of error E equal to 2 milliamps and expected value 20 milliamps. Simplify them, then you will get 10%. So this is the basic idea about the error. So next one, sensitivity. Sensitivity means ratio of change in output to that of change in the quantity being measured. So actually here we have two types of sensitivities. First one, linear sensitivity. Second one, incremental sensitivity. For better performance of the system, the sensitivity of an instrument should be high. So these are the static characteristics. Static means memoryless. All are belonging to present case. Next, I am going to explain types of errors. There are three types of errors. One is the gross error, second one systematic errors, third one random errors. Gross errors are the human errors caused by the operator or person. Simply you can say human mistakes. Gross errors will occur in such a manner: taking wrong readings, reading with parallax error, incorrect adjustment of zero, improper applications of instruments, wrong calculations. So by the taking small precautions, we can avoid such type of problems. Next one, systematic errors. Systematic errors divide into two categories. So one is the instrumental error, second one is the environmental error. Instrumental errors occur due to shortcoming of the instrument. This type of errors can occur due to the reasons of bearings, irregular spring tensions, aging problem, faulty display circuit. So generally for analog systems, we have in the meter we have bearings and frictions. So definitely we will get some problems in the bearings and spring tensions. So we can avoid this type of errors taking some precautions like selecting suitable instruments, applying correction factors. Second one, environmental errors. Environmental errors occurs due to external conditions affecting the instrument. Here external conditions means temperature, pressure, fluidity, magnetic and electrostatic fields, dust, improper housing of the instrument. By the taking small precautions, we can avoid such type of problems. So like as air conditioning, magnetic shielding, cleaning the instrument, housing the instrument. So these are the environmental errors. Next one, random errors. Here, random errors are the gross errors and systematic errors can be avoided by taking proper care. Some other errors can also occur in measurements. No specific reason can be assigned and precaution could be taken to avoid these errors. Such errors classified as random errors. Actually, this type of errors can occur due to the reason of noise. So now with the help of some mathematical calculations, we can avoid random errors. Here we are taking statistical approaches. So here we have 5 types of statistical approaches. Arithmetic mean, deviation from the mean, average deviation, standard deviation, variance. So these are the statistical analysis process. To calculate these values, now you have to consider group of readings. So actually, to calculate random errors, you have to collect some group of readings. By the calculating using statistical analysis, so we can identify random errors. So now I am going to explain arithmetic mean. Here, arithmetic mean is the average of the group of readings. Here I am taking group of readings as x1, x2, so on, xn. So this data having n values. So now I am going to calculate arithmetic mean of the group of values. So here arithmetic mean x bar equal to x1 plus x2 plus so on plus xn divided by number of readings. So you can calculate arithmetic mean x bar equal to summation xn divided by n. So now I have taken one example. Consider group of readings are 49, 51, 52, 50, 49. Calculate the arithmetic mean. So already you know the value of the arithmetic mean. Here arithmetic mean equal to x1, x2 plus so on xn divided by small n. So here I am taking group of readings as 5 values. x1 is equal to 49, x2 equal to 51, x3 equal to 52, x4 equal to 50, x5 equal to 49. Substitute in the formula, then you will get arithmetic mean x bar equal to 50.2. So this is the first one. Second one, deviation from the mean. This is the departure of a given readings from the arithmetic mean of the group of readings. The deviation from the mean for the given readings can be written as d1, d2, dn. Now calculate first deviation d1. Here d1 is equal to first reading x1 minus arithmetic mean x bar. d2 is the second deviation. This is from second reading minus arithmetic mean. So on Now in the same way, write for deviation for n values, dn is equal to xn minus x1, where x1, x2, so on xn are the given readings, x bar is the arithmetic mean. Here the deviation either may be positive or negative. The algebraic sum of all the deviations must be 0. That means here d1 plus d2 plus d3 plus so on dn is equal to 0. So this is the basic idea about deviation from the mean. So now I will explain deviation from the mean for the given values. So actually previous I had taken one problem. By using the problem I have calculated arithmetic mean. Now I will take same problem to explain deviation from the mean. So in previous I have taken group of readings as x1, x2, x3, x4, x5. x1 is 49, x2 51, x3 52, x4 50, x5 49. Already know the value of arithmetic mean x bar is equal to 50.2. This is from previous problem. Now I will calculate first deviation d1 is equal to x1 minus x bar, where x1 equal to 49 minus x bar 50.2. So now we will get deviation is equal to minus 1.2. dt equal to x2 minus x bar. We know the value of x2 51, x bar 50.2, deviation 0.8. d3 equal to x3 minus x bar is equal to 52 minus 50.2 is equal to 1.8. d4 equal to x4 minus x bar. We know the value of x4 is 50, x bar is minus 50.2, then deviation minus 0.2. d5 equal to x5 minus x4. We know the value of x5 equal to 49 minus 50.2 is equal to minus 1.2. Now add all the deviations. That means summation d is equal to d1 plus d2 plus d3 plus d4 plus d5. Add them. So then you will get 0. Now our condition is satisfied. So this is the idea about deviation from mean. Next I am going to explain third one, average deviation. Average deviations is an indication of precision of the instrument used in measurement. So actually here accuracy is a precision. Precision is not a accuracy, because of to calculate precision now you have to consider some group of readings. Among that readings you have to choose some particular value. With the help of that value you can calculate precision. So that the reason you can say here precision is not accuracy. So according to the definitions now, here average deviation may be expressed as DAV is equal to modulus D1 plus modulus D2 plus so on plus modulus Dn divided by n. So now I am going to calculate average deviation from the given values. So earlier I have taken some group of readings are 49, 51, 52, 50, 49. So already I have calculated arithmetic mean and the deviations. So here arithmetic mean x bar equal to 50.2. By the using arithmetic mean, now we calculate each deviation. Already we have calculated d1 equal to minus 1.2, d2 equal to 0.80, d3 equal to 1.8, and d4 equal to minus 0.2, d5 equal to minus 1.2. I have taken 5 readings. Now substitute here and simplify them, then you will get d AV is equal to 1.04. That means your average deviation is equal to 1.04. This is the idea about average deviation. Next one, I am going to explain standard deviation. Standard deviation may be expressed as sigma. The standard deviation is the square root of the squares and sums of the deviation. So here, based on n values, now we can decide the standard deviation value. For n less than 20, you should write sigma is equal to under root d1 square plus d2 square plus d3 square plus so on plus d square n divided by n minus 1. For n greater than 20, you can write standard deviation is equal to under root of d1 square plus d2 square plus d3 square plus so on plus d square divided by n. So standard deviation is also called root mean square deviation. So now I am going to calculate the value of the standard deviation for the some given group of readings. Earlier I have taken some group of readings. Now I will take same examples, same readings for the calculate standard deviation. Already know the value of d1, d2, d3, d4, d5. So here d1 is the minus 1.2, d2 is the 0.80, d3 is the 1.8, d4 is the minus 0.2, d5 is 1.2. So here I have taken readings n less than 20. That is the reason I have written in the place of n as n minus 1. Okay. Now simplify them. You will get the standard deviation sigma equal to under root 1.7. Next one, variance. Here variance V equal to sigma square. So that means variance is the square of the standard deviation. That means you can write d1 square plus d2 square plus so on plus d square. For n greater than 20, write divided by n. For n less than 20, you can write variance V equal to sigma square d1 square plus d2 square plus so on d square n divided by n minus 1. So by the using above two formulas, you can find value of the variance. Already I have calculated variance for the given values. In the previous problem, I have taken some readings, group of readings. So by using that readings, I have calculated variance. Already know the value of d1, d2, d3, d4 and d5. Substitute here. So then you will get our variance V is equal to 1.7. So actually all 5 are the way to calculate random errors. So by using the statistical approaches, you can identify the random errors. So easily you can solve these problems. Next one, dynamic characteristics. The dynamic behavior of the measuring system determined by applying some known and predetermined variations of the input to the sensing element. So actually here dynamic means this is the some standard. So that means to remember dynamic characteristics we need some memory. That means to remember this type of dynamic characteristics, so we need fast input samples and future input samples and future output samples and fast output samples also. In the same way, we need help of the present input samples also. So to remember this type of characteristics, we need help of the some standard variations in the input used practically to obtain the dynamic behavior. So generally here I am trying to take 4 input signals. One is the step input. A step input means sudden, instantaneous and finite change in the input. So next ramp input is the linear change in the input. It changes at constant rate with respect to the time. Next, parabolic input, an input signal which is proportional to the square of the time and hence represents constant acceleration. This is the parabolic input. Sinusoidal, next one, fourth one, sinusoidal input, an input which changes in accordance with sinusoidal function of constant amplitude. So generally, suppose one system is there, the system has given input in the output in the form of sine wave. Now we can say our system is perfect. Actually, generally for linear system, input is sinusoidal and output is also sinusoidal in steady state. So these are the values to explain dynamic characteristics. So here we have 5 types of dynamic characteristics. The various dynamic characteristics of the system can be obtained: speed of response, fidelity, lag, repeatability, reproducibility. In the next session, I will explain dynamic characteristics of measuring system. Okay, thank you.